Hi, I'm Amy Bourgeois from WPI Graduate School of Engineering. My project was on kraft pulping and the environment. Kraft pulping is one form of chemical pulping for the paper industry, and this graphic shows wood going into pulping and then paper manufacturing. Paper has been used since 3000 BC. It was originally made by pressing papyrus to form thin sheets. After that, fibers from bamboo, rags, bark, or other materials were soaked in calcium hydroxide solution to form a pulp and then dried into sheets. Pulping is the separation of the desired fibrous material, which is the cellulose in wood, and separating out the unwanted lignin. It's also sometimes called delignification, and different raw materials have different amounts of lignin and cellulose. Mechanical pulping is the method of grinding wood chips into smaller particles, which are then suspended in a liquid solution to make the pulp. Thermal uses saturated steam to heat and moisten the wood and remove the lignin. Chemical pulping involves solubilizing lignin in an alkaline, neutral, or acidic water-based pulping liquor, which may have chemicals such as sodium hydroxide or sulfite ions added to increase that solubility. Different raw materials that are used to produce pulp can produce different quality pulp and then different quality paper once it's dried. Materials with longer fibers give higher physical strength paper. Shorter fibers give lower strength but higher surface quality. Wood is the major source of the world's paper production, over 90%. These can be either hardwoods or softwoods, and these vary in the different lignin and cellulose concentrations. As we said before, softwoods tend to give the higher quality, stronger papers. Non-wood sources include bamboo, sugarcane, reeds, hemp, or some agricultural waste. These have to still have that fibrous material that can give strength and structure to the paper. Often these are naturally brighter, so they don't require as much bleaching. Kraft pulping is the most heavily used pulping method worldwide. It uses a sodium hydroxide and sodium sulfide solution at high temperatures to dissolve the lignin. It's more selective than other methods, meaning that it retains more of the carbohydrates intact, leading to higher yields and stronger pulps. Here's a process flow diagram of the kraft pulping system. On the left, you see all the pretreatment steps, and then the chips go through digestion and liquor, depressurization after rinsing, and then any optional bleaching. The spent black liquor from this process is then concentrated at high temperatures and then combusted. The inorganics that remain after that are dissolved in water to form a green liquor, which is then treated to produce a new white liquor, which can then be recycled as the starting material for this process. There's a lot of combustion products that are formed during the liquor regeneration process. Particulate matter, any sulfur oxides or nitrous oxides, and these have to be limited their discharge. There's also reduced sulfur compounds that contribute to odor concerns. Wastewater from kraft plants typically have high solids and oxygen demands because of all the organics that were dissolved in solution. pH can also vary. The pretreatment standards that are set by the EPA focus on biocides that are used or chlorine-containing bleaching chemicals. Organosolve pulping, which uses alcohols, acids, or other organic solvents rather than the white liquor solution, does incur higher solvent costs, but these can be offset by lower capital investment costs and higher yields if these are pretreated with a fungi that can attack lignin selectively. Paper recycling benefits manufacturers since paper that's recovered can be entered into the manufacturing process at a later stage. It doesn't have to go through all the delignification. Plantation forests can be reduced also, which can be more susceptible to pest invasion. The American Forest and Paper Association estimates that in 2011, 67% of all U.S. paper was recovered for recycling, and this can lower the demands on traditional forests as population and paper demands increase. Changes in print media, newspapers, magazines, and books. There's been a drop-off in the recent past and projected to increase in the future. The demand for print quality paper has been decreasing. In the future, if different qualities of papers are required, such as print media dropping off and that shift towards maybe packaging materials, different types of feed material can be used since fiber content, fiber diameter, and lignin content change the quality of paper. The company Arborgen has a R&D project for freeze-tolerant eucalyptus trees, which is currently under review by the Department of Agriculture. These are the fastest-growing hardwood trees, and they are adaptable in colder climates, so they can produce larger amounts of pulp for paper specifically. Kraft pulping has historically been the most widely used pulping method because it does produce strongest pulp. These require large mill sizes for return on investment, high water usage, air and water pollution in the treatment, Alternative solvents and fungal pretreatment present attractive new options in addition to non-wood sources in the future.